people in Africa versus people in Asia or in the Caucasians, genetically speaking, they're the same. But physically, they look different.
Science has proven that Africa has the oldest and most genetic variation in the world. One thing that stands out here is that you see so many people who look different. Television, books, movies, magazines, and other media outlets have all played a vital role in forming stereotypical images of Africans, such as coarse hair, jet black skin, wide noses, and thick lips. But once you travel here, in particular East Africa, you find out that's not the case. Dr. Sheikh Anta Diop is arguably one of the greatest anthropologists of all time. In his book entitled The African Origins of Civilization, Myth or Reality, Diop unveils what could be the missing link that gives us a clearer picture based on physical anthropology on how human phenotypes evolved. He says, and I quote,
"There are two well-defined black races. One has a black skin and woolly hair. The other also has black skin, often exceptionally black, with straight hair, aquiline nose, thin lips, and acute cheekbone angle. We find a prototype of this race in India." End quote.
So the question is, how can you have two different populations, both with jet black skin, but one having woolly or coarse hair, a wide nose, and thick lips, and the other having straight hair, a thin nose, and thin lips? And how can you have different populations such as in Asia, Europe, South America, and all over the world with different hair and facial features? The answer lies in genetic diversity.
Africans are very diverse. If I compare, say, the San to the Yoruba or something like that, they're not very similar to each other genetically. And in fact, at the level of genetic diversity, about the same level of genetic diversity as if I compared the San to a population like the Caritiana that live in South America.
The biggest mistake that any individual could make would be to assume that all Africans look the same. Genetic variance explains to us that the older the population, the more differences you will encounter.
When you look at the genetic variation today in anatomically modern Homo sapiens, there is more variation among Africans than there is among Eurasians or any other populations around the world. Now think about this. Why do we have more variation among Africans than we have among Eurasians? What that means is the gene flow has been going on for much longer time in Africa than it did in the other parts of the world.
Indeed, Africa does have the largest amount of genetic diversity in the world. You'll never find a place in the world where people are so different genetically. So why is that, and what does it mean? DNA is the molecule that actually forms our genes. Each of us have inherited 50% of our genes from our mother and 50% of our genes from our father. But sometimes the genes that we receive from our parents aren't copied correctly by us, thus causing the gene to change. This is what's known as a mutation.
Now, mutations are not a bad thing. Actually, they're a good thing because without them, all humans would look the same. Mutations occur in each generation. Simply put, the more mutations that occur over time, the more genetic diversity will occur. For example, the origins of our species have been traced back to Africa roughly 200,000 years ago. Now, if a generation is 20 years, then that's 10,000 generations of genes mutating. This explains why Africans look so different, because so much time has accumulated to form changes in their genes. On the flip side, the younger the population, the less genetic diversity occurs. In other words, there are less mutations that have occurred over time. For example, it's estimated that the population of Europe evolved around 30,000 years ago. Now, once again, if a generation is 20 years, that's only 1,500 generations. That means that the population will have less genetic diversity, causing it to look more the same. The following section will discuss how genes in a population behave over time by focusing on genetic diversity, genetic variants, founder groups, and genetic isolation to explain how these diverse Africans migrated out of Africa and populated the entire world.
Genetic variance refers to the differences in gene frequency in individuals. In other words, when you think of genetic variance, think about the genes that are inside of us that produce the unique features you see in different populations, such as Asians, Europeans, and Africans. We have genes that define our hair color and hair texture. Genes that define the shape of our eyes. Genes that define the thickness of our lips. Genes that define the shape of our nose. And genes that define our height. The driving force that causes our genetic variance are referred to as genetic mutations. During reproduction, when the male sperm fertilizes the female egg, an offspring is formed. While the offspring is forming inside the female, it's copying the 3 billion nucleotides it's receiving from its father and mother. But while the copying process is ongoing, a small copying error is occurring every 1,000 nucleotides. As a result, the copying process is almost perfect, 99.9% to be exact. The 0.1% of the genes that weren't copied correctly is called a mutation, which means a change in the DNA sequence. These mutations occur every generation. Although these mutations may seem small, when multiplied by thousands of generations, we begin to see unique genetic lineages developing as a result.
When thinking of mutations, there are two things you should remember. First, the definition of mutations, which is random changes in a DNA sequence. Now, the word random means occurring by chance or occurring without definite aim or purpose. There's no scientific explanation to what causes our genes to mutate. The second thing to remember is that mutations are a permanent change in our DNA. You can't change the genes you've inherited from your parents, and you can't control how your genes will be passed down to your offspring. For example, as mentioned earlier, all humans have 3 billion nucleotides residing in us that we've copied from our parents. Now, if I program this copying machine to make 3 billion copies of this paper, all of the copies won't come out like the original. Some are going to have mutations or changes in them. For example, some copies may have a short mark on them, while others may have a long mark on them, while others may be lighter due to ink malfunctions. Now remember, this mutation from the original copy is permanent. So now if I take those copies that have a short mark on them, such as this one, and make 3 billion copies of it, those copies are going to have the short mark on them, along with any other mutations or changes that will happen along the copying process. This explains why you see people who live around Asia where their eyes appear to be smaller. Actually, their eyes aren't smaller than anyone else's, but a mutation occurred in their DNA sequence thousands of years ago where they developed what's known as an epicanthal fold, which is the skin fold of the upper eyelid covering the inner corner of the eye. Now remember, the mutations are permanent, so they mated and created offspring with epicanthal folds as well. We'll discuss this later in the documentary in what's called founder groups and genetic isolation. Again, no matter what we look like on the outside, we're 99.9% the same on the inside. Think of it this way. If you ask me if I have change for a $100 bill, and I say not exactly, but I have $99.90, your response would probably be, that's fine, I'm only missing a dime. Well, that dime, that 0.1%, is the difference between all humans, which is caused by the mutation process that was just covered in this section.
From our ancestors living in a small population in Africa around 200,000 years ago to over 7 billion people on the earth today, mutations have played a major role in the evolution of our species. From these mutations comes genetic variants.
There was like one group that left Africa, and they weren't big enough to take all, that group wasn't big enough to contain all of the variation that was in Africa. But all of the people outside of Africa are descendants of that one group. So that group had a subset, and all of their descendants have that subset, nothing more, maybe less, but nothing more than that subset that the first group that left carried.
When geneticists study your DNA, they're actually studying the history of your genes and the history of the people who gave you your genes. Commonly used terms such as genetic variants, genetic diversity, and mutations can oftentimes get confusing. So let's look at this example using alphabets to help you understand how this works. In our alphabet, there are 26 letters ranging from A to Z. Now imagine all of the letters are in the continent of Africa and no place else. Now, the same way each letter is different is the same way people within the population were different due to the mutations or changes in their genes over so many generations and generations of humans reproducing. Once again, this is known as genetic variants, variety or differences within our genes. Genetic variance is what makes us look different because we have different genes coded for different parts of us, such as our hair texture, our nose size, the size of our eyes, our height, etc. Now, once again, all of the 26 letters represent the diverse populations and genetic variants that were in Africa at the same time before our ancestors moved out. Now, when our ancestors started to move out of Africa, the entire population didn't move out. Only a small subset of the population moved, which carried with them their genetic variants to their new location, as Dr. Long mentioned. For example, the population that migrated to Australia took with them their genetic variants that are represented by the letters A, D, G, L, O, and Z. The population that migrated to Eurasia took with them a subset of the genetic variants from the group who moved to Australia, which are represented by the letters D, G, and Z. Now, the correlation is that they all share a genetic link to their ancestors who lived in Africa. Once again, this is why geneticists say that Africa has the oldest genetic variants in the world because of the gene flow. The mutations that occur in every generation has been going on longer there than any other place in the world. In contrast, younger populations, such as the European population, has less genetic variants due to less time the mutations of genes have been occurring. This is how geneticists can trace all humans back to Africa by analyzing our genes and finding a common marker in us that will eventually lead back to the first population in Africa. Now, let's look at their incredible journey out of Africa.
Modern humans originated in Africa, and they left Africa for the first time probably after 200,000 years ago.
So these populations of Homo sapiens that came from Africa at some point started to radiate, and then they moved across towards the southeastern part of Asia, across the Indian Ocean, so through probably Afghanistan, Pakistan, India, and all into that southeastern Asia part.
To gain a better understanding about the migration of our ancestors from Africa to the Far East, I came here to India to retrace their footsteps. Now, India has a population of 1.2 billion people. In fact, 1 in every 6 people in the world reside right here. That's almost 20% of the world's population living in this one country alone. What's so significant about the people who live here in India is that they are a mirror reflection of exactly how anthropologist Dr. Sheikh Anta Diop described the second African to be, with straight hair, thin noses, and thin lips. What also is so significant about the people who live here is their extremely dark skin. Science, biology, and genetics all concur that people with light skin cannot create people with dark skin. With that theory being rejected, it gives us a clearer understanding of why these people's skin is so dark. It's because they are the descendants of the original people who made the first migration out of Africa. It also strongly suggests that the ancestors of these people with straight black hair, thin noses, thin lips, and extremely dark skin are the progenitors of the first people to settle in Europe.
Humans have lived in Africa far longer than anywhere else in the world. In fact, science tells us that around 150,000 years ago, all humans lived on the continent of Africa and no place else. When modern humans first migrated out of Africa thousands of years ago, they did so in small groups. These small groups were a subset of the African population because only part of the African population migrated out of Africa. Only part of Africa's small mutations that make up our genetic variants, such as different hair textures and different facial features, moved with them to the new regions that they migrated to. This is what's known as a founder group.
I had one founder group leave Africa and form the Eurasian population. And then the founder group that formed the Americas left Eurasia to form the Americas. So they had a subset of what was in Eurasia, which was a subset of what was in Africa. One of my graduate students and I have been combing these large genomic databases that have hundreds of thousands of markers in them. And I think we're working on one set that has something like almost 1 million markers on different populations around the world. And we ask the question, well, can we find some marker that is common in Europeans and not seen in people, Asians or Africans or things like that? We couldn't find one.
As founder groups such as this one migrated to new uninhabited places, they began to produce offspring. As a result, their features were passed down through their genes to their children. Those children continued the cycle by growing up and producing their own children. With these populations with similar features continuing to produce offspring in different areas of the world for thousands of years explains why so many people around the world look similar that live in the same regions. This is what's known as genetic isolation.
Genetic isolation is when you have small groups of people, such as the first populations to migrate out of Africa thousands of years ago and settle in foreign lands, and to reproduce offspring without any admixture from outside population.
They would inhabit a new region, and they would be isolated from the group that they came from. And we had a series of these, a succession of them that populated people throughout the world. And eventually you would get the a population that had more of the characteristics of, the first ones that had that sort of trait.
There are still groups in Melanesia that look more African than they look Asian, because they just stayed there.
For example, genetic isolation explains why there's such a high concentration of people with extremely dark skin and straight hair in eastern countries such as India, Pakistan, and Ethiopia. Genetic isolation also explains why there's such a huge population of people with epicanthal folds, causing their eyes to look smaller, living in and around Asia. Genetic isolation is the reason why there's a high concentration of people with blonde hair and blue eyes in Scandinavian countries such as Sweden, Norway, and Finland. These populations that would have normally remained isolated began to move to new regions and mix with the indigenous population and reproduce offspring. This mixing phenomenon produced the different phenotypes you see in humans today.
So in essence, when you see different phenotypical traits in people, it's not difficult to comprehend if you understand genetic variation and genetic isolation.